Hello and welcome back. This is Mr. Spinks. We are in section 11.3 and this is the second video and last video section 11.3. It's also the last video chapter 11. So hey, there you go. You absolutely need a calculator for this. Just like you did yesterday, you should know by now if you're not entering this into a calculator and getting the same answer that I am, that you're going to miss it on the test, on the starters tomorrow, and on everything. So get your calculator, please, and pay attention. Now, all this is today is compound interest with a little twist. Same formulas, just, little adjustments. Let's talk. Says Kevin invested $925 in an account with an interest rate of 11%, compounded semi-annually. How much interest did he earn at the end of 4 years? There's a little trick here, but I'm going to lead you through this and see if you can figure out where the little mistake happened. The formula for compound interest, again, is that A equals P times 1 plus R over N, trying to make my R look different than my N, to the NT power, N times T. That's the game. So let's identify our pieces right here. The P is $925. That's what's being put in the account. The interest rate is 11%. I will turn 11% into a decimal by moving the decimal point back 2 places. Our R is 0.11. It'll be in the bank for 4 years. That's the T value. And we got to find the N. How many times is this compounded per year? Well, it's compounded semi-annually, and semi-annually indicates twice per year. So we're going to plug in all of our pieces. Our A is going to equal, the P in this case is $925 times 1 plus, our R in this case was 11%, so 0.11 divided by, the N was 2, and this is all going to be taken to the N times T power, which is 2 times 4. We talked yesterday, multiplying the exponent first does help. 2 times 4 is 8, so we've got 925 times 1 plus 0.11 divided by 2 to the 8th power. From there, that's a calculator move. Plug all that into the calculator. Make sure you get the right result. At the end, I got a total of $1,419.59, if rounded correctly. Now you may look and go, hey, we found our answer. We're in good shape. No, you're not. You're really close, but you're not. See, this question didn't ask how much money was in the account after 4 years. It says how much interest did he earn at the end of 4 years. Guys, interest is like profit, okay? So what you got to think in this case, well, he put $925 in the bank, or in the account. At the end of 4 years, he's got this amount in the account. How much money did he gain? Well, to determine that information, we're going to apply a little subtraction. Because if we were to subtract out the original total from the amount that was invested, it's going to provide us with our answer of how much money he actually physically made in this case. In doing our subtraction, we should come up with a value of $494.59. And that's the amount of money he actually made. That's the interest that was earned. So there's just a little twist going on, just a little adjustment, okay? Be careful and make sure you read everything very carefully. All right, so we have our compound interest in our present value formula. And our present value formula is very similar to our compound interest formula with a little twist. So that you know, when you are using your present value formula, you use this when you want to have a certain amount of money after a certain number of years. What I'm saying to you in this case, you're going to actually know what the A is, the amount of money you want to have. And all the other problems we've been doing, we've been working with how much we put in the bank. Well, this is going to ask you how much do you need to put in the bank if you want a certain amount of money later on. So that's the key. You're going to know how much money you want later on. Look at an example. Find the present value you should invest. What should you put in the bank? They're asking for P. If the desired accumulated amount is $100,000 after after 4 years. So you want to have this. This is what you want to have. What you want to have is always A. And that's how I know that we're not using our A equals P times 1 plus R over N to the NT power. I know this one's out at this point in time because this is what I want to have. It's not what I'm putting in. It's what I want to have. And we use this one when we know what we're putting in the bank. Rather, we are going to use P equals A divided by 1 plus R over N to the NT power. Okay? So it's just a little switch going on. From here, I'm going to plug in the information, but that's the first step. From now on, you got to determine which one of these two formulas you want to use. Do you know what you're putting in, or do you know what you want to get out? That's how you determine it. So as we look at our formula, the A in this case is 100,000. That is what we actually want to get out. So that's on top. Let's look through it again. It's at 4 years. That's our T value. T is 4 in this case. Moving on from there. Let's clean that up just a little bit. Let's just clean the whole thing up. It was all messed up. So our T value is 4. Looking through the rest of it, it is 4%. 4% as a decimal is 0.04. And then we always just got to look for the compounding period. How many times is it compounded per year? Whereas compounded quarterly. Quarterly happens 4 times per year. So P equals, the A was 100,000 divided by 1 plus R over N. R is 0.04. And in this case is 4. And that is all taken once again to the NT power, which is 4 times 4. Once again, I will multiply the exponent first. 4 times 4 is 16. So my P is going to equal 100,000 divided by 1 plus 0.04 divided by 4, all taken to the 16th power, and the denominator is all taken to the 16th power. Plug all that into the calculator. If you do it correctly, you should come up with an answer at this point in time of $85,282.13. Check that one definitely, guys. Let me know if there are questions when you come into class tomorrow. All right, last one we've got. On the last one we've got here. How much money should parents invest at the birth of their child to provide the child with $50,000 at the age of 18? They want to give their kid a good college fund. They want to send them away to college, okay? So you look at it and you say, which formula do I want to use? Do I want to use A equals P times 1 plus R over N to the NT power? Or do I want to use P equals A divided by 1 plus R over N to the NT power? Well, as I look at this situation and make that determination, I'm looking to see, do I know what I'm putting in or what I want to get out? And this says the amount of money is the amount of money they want in 18 years, or at the end of it. That's not what we're putting in, that's what we want to get out. Therefore, this one's out, and this guy's our winner. Once again, that's because we don't know what we're putting in. We know what we're getting out of the account. The $50,000 is the amount of money that we want to have after 18 years when the kid's 18, so that's the A. Oh, let's see, at the age of 18. Well, if we want to have the money when the kid's 18 and they're investing it when they're born, the actual amount of time that'll be in the bank is 18 years. It's a little trick there, but not too hard. Moving on, it's 8%. 8% is 0.08. And now you're looking for your N. How many times is this compounded per year? Well, as we look, it says quarterly. Quarterly indicates the N is 4. And these are all the pieces that we're going to plug in. So, if our P equals, the A was 50,000, divided by 1 plus R in this case is 0.08. The N in this case is 4. And we are taking this to the NT power. Well, N is 4, and T is 18. I'm once again going to multiply this exponent first. 4 times 18 is 72. So the P will equal 50,000 divided by 1 plus 0.08 divided by 4 to the 72nd power. Compute all that through and see what you get. My final answer that I got for P is $12,015.97. And if and when you get that value, I want you to think about that for just a second. Because, guys, in the problem, it said they wanted $50,000 when they're 18. Well, if you invested a little over $12,000, you could have $15,000 or $50,000 in 18 years. Kind of shows you why people invest early for kids' college funds.